First thing I'm going to do with this problem, I'm going to rewrite it because I don't particularly like fractional exponents. And the way I'm going to explain this, it'll make more sense in a second. When I say something, you're going to be like, oh, okay. So I'm going to write this as the square root of x plus 5 minus 2 equals 1. Now, I am going to be super particular. Make sure that when you're writing these problems, because sometimes when y'all are writing, you don't pay attention to what you're writing and you confuse yourself because you write one thing and then you read it and you're like, wait, I wrote this and it's something completely different than what it's supposed to be because you're not paying attention to what you're doing. So there is a habit, and y'all don't do this often, you don't do it on purpose, but there's a habit just to keep drawing this line out, and that minus 2 ends up being underneath the square root. Make sure that it is not underneath the square root, because if you think it is, that's going to change the way you approach the problem and it's going to change your answer. So make sure when you're rewriting these problems, write them down accurately, that even your square root symbols go where they need to go, because you want to be 100% accurate so that you have a better chance of getting the correct answer. Okay, so if I said, hey, we're solving these. Well, first of all, how do you know that you're solving these and not just like doing some like simplifying? Equal sign. There is an equal sign in these problems. And equal signs do not just magically appear in the middle of problems. They have to be there from the beginning. So we're not magicians. We don't just say poof and there's an equal sign there and then we cross multiply, because sometimes these things happen. I don't know how, but they do. But if I'm solving this, then the idea of solving is to get x by itself. How would I do that? Sure, add 2 to both sides. That looks a lot better, doesn't it? Square root of x plus 5 equals 1 plus 2 is 3. Okay. That's what we're going to do next. I want you to make a note here, and I want you to make this really big. And I want you to write, isolate the radical. I want you to write isolate the radical, because that is going to be your first step every single time. You need to isolate the radical. When I talk about the radical, what am I talking about? The square root symbol. What are the cube root symbol? Because sometimes you will have some cube roots today, but I'm talking about that root symbol that we have there. So we do need to isolate the radical. That is important. And then after we've got the radical isolated, we can do some math. And I'm going to go back and I'm going to show you why we isolate the radical in a second. But for now, let's just work on this. So to solve this, someone over here said what we need to do next. I don't know who it was. Lauren, what'd you say? We square both sides. Why would we square both sides?
It undoes the square root.
Because squaring undoes a square root. So once I square, then I can get rid of that square root symbol. They cancel each other out. And on the left side, I'm just left with what? X plus 5 equals, what would it equal? 9. Okay. Then I subtract 5 from both sides, and what do I get as my answer? Okay. So let's talk about why we need to isolate the radical. So I'm going to rewrite the original problem. Well, the rewrite of the original problem. Square root of x plus 5 minus 2 equals 1. Don't write this, okay? You don't need to write this. So same idea would apply, that in order to get rid of the square root, what would I have to do? Square both sides. Again, you're not writing this. Okay. I need you to understand that when we square both sides, that means that I am multiplying something by itself. If I'm supposed to multiply this, what do I have to do? Distribute. Do I just do this and this? No. Because what's our acronym that we use for this? FOIL. Yes. We have a problem, and this is a generic statement that even my kids last year dealt with, and kids in other classes deal with. We don't FOIL, we FLA. We have a tendency to just do the F and the L part of this, and we forget the OI in the middle, which is critical, okay? So you have to make sure that when you do these problems, you FOIL. Now, would you want to FOIL that problem? Why not? There's too many square roots. That's why we isolate the radical. Because when we isolate the radical, we don't have to do all of that. Page 678, problem 3. Page 678, problem 3. Okay. Is my radical isolated?
Where?
In problem 3 on page 678.
Yes.
Okay, what does it mean to be isolated, by the way? Alone. Okay, it's isolated. So what do I need to do to get rid of it?
Square root.
Not square root it. Square it, because I need to get rid of it. It's already square rooted, so I need to square both sides. Okay, so on the left side, what happens when I square a square root? It cancels. It disappears, and I get left with x plus 3 equals. And this is the tendency, is to tell me the right side. Don't write this. Tell me it's x squared plus 1. No, it's not. What do you have to do on the right side? You have to FOIL, because you have to remember that x plus 1 squared is really x plus 1 times x plus 1.
Oh my god.
What kind of problem is this going to give us when it's all said and done? Quadratic. So how can we solve quadratics?
Quadratic formula.
Ooh, we can do quadratic formula. What else can we do? We can factor. Yay! The things y'all love doing so much.
Already factored in that state.
Yes, it is, but I have to do something with this x plus 3 here. And in order to actually solve it, I need my quadratics to equal what?
0.
Always. So to distribute on the right side, x times x is, okay, first outside, because I need to do the OI part of FOIL, not just the FLA, plus 1x, plus 1x, plus 1. So I get x plus 3 equals x squared plus 2x plus 1. And next step, what do? Okay, I need to subtract the x and the plus 3 from both sides because I need to get these to equal 0. We said that a second ago. Quadratics always need to equal 0. If they don't, we can't actually do anything with them. So I get 0 on the left side equals x squared plus x. Okay. And my options are, you told me a second ago, what are they? Quadratic formula or factoring? Factoring should always be your first choice because it's always easier. Quadratic formula always works, though. That's the good thing about it. Factoring doesn't always work. But does this problem factor?
Yes.
How?
X plus 1, x plus 1. I mean, yeah. X plus 1, x minus 1, not that.
X minus 1 and x plus 2.
Oh, my bad.
X minus 1 and x plus 2. So I end up with how many different values for x? 2. So what's the first answer I come up with? X equals 1, and my second one is? Okay, how are you getting this? Because some people I know are still struggling with that. So I'm not disagreeing with you. But what math do we do to prove that that's what our answers are? Okay. The zero product property, that's like the fancy name for it, says that if I'm multiplying two things together, x minus 1 and x plus 2, and when I multiply those two things together, I get 0, then one of two things must be true. Either x minus 1 must equal 0, or x plus 2 must equal 0. And we solve both of those, and that's where positive 1 and negative 2 come from. Okay. This is all I'm going to go through today. We are not actually done. There's still 10%, and that 10% that I have left is critical, but I'm going to do that part on Friday. So, because we're going to talk about why some of these answers don't actually work.
Alright.
It's fine. We're good. Remember when we solved rational equations and we had excluded values and we had real answers, and sometimes our real answer was our excluded value? So it's kind of that same idea. We're going to talk about that part on Friday. That's the easy part. If you can get here, then I can get you the rest of the way. So you've got your homework is 2 through 16 even, 21 and 23. I mean, I can give you more problems.
You and your 23.
It's a good problem. Okay, your homework 2 through 16 even, problems 21 and 23, and it's going to be due on Monday, and that day will not change. It will for 100% guaranteed for sure be due on Monday.